Hi everyone, and welcome to our video on graphing a shifted tangent curve. So in the previous video, I'm going to scroll, we just did a cotangent curve, but if we noticed, it was pretty much the same process as doing a shifted sine or cosine curve. We just need to make sure our shapes are good and that our period equation is the correct equation. Okay, so a tangent curve looks something like this. At least that's one way to graph it. If needed, we said, okay, the blue right here in this picture shows if we needed to see it in one full branch. Okay, so this we don't see a full branch. We see it's kind of broken up. All right, but it's still good. It should be good if they say graph one full period, which is mostly how they want us to do things. All right, so back to the actual problem. So like the one above, let me also scroll back, we need it in the correct form. Okay, so remember if there's ever a number attached to x, but then also minus or plus another number, we need to change it so that we have a bracket and then x should have a coefficient of 1 on it inside the parentheses. So we'll just factor out whatever we need to factor out right away. Okay, so let's get in the correct form first. So f of x equals negative tangent, and then let's get a bracket. So x over 10, that x does have a 1 there. 1/10 is what instantly needs to get factored out. And then that way I would have x plus blank bracket, and then let's get the minus 2 as well. Okay, so we're just making that adjustment. Now, you can guess and check. As long as you distribute it back in to verify that we have up above, it's fine. However, one of the ways that we did this, we said the second number in that parentheses divided by the first coefficient should give us what goes in that parentheses there. Okay, so keep the first fraction, change to multiplication, flip the second fraction. The 10s cancel, and we have 3 pi. So that's what goes in that missing spot. And then I'm going to show in blue, the 1/10 you can distribute. And notice it matches the x over 10 plus 3 pi over 10. Okay, so always check no matter what. Okay, so that is the correct form at least. And now that we have the form, we go about and find all of our information. So we have a is -1. Also remember they might use different letters than what I'm using, but they're all the same things. So a is -1, and because it's negative, I'm going to say, well, we should reflect across the x-axis. But let's get our other information. So there's our b. Our b is 1 over 10. The period of a tangent function is always pi, just pi, divided by whatever b is. So it would be divided by 1/10. And then we can multiply both top and bottom by 10 in this problem. So the 10 and the 10 cancel down below. We would be left with just 10 pi for our period. And then we have, let's mark them in blue, we have the phase shift. Okay, so x plus 3 pi means the phase shift is -3 pi, or left 3 pi if you want to use the words. And then this -2 is where the vertical shift would be. -2 means we would go down 2. So let's put left and let's put down. Okay, so we have that information now too. Okay, so now that we have all of this, just like the previous problem and just like sines and cosines, what I really want to do first is just graph non-shifted, which is based on this black ink information. Okay, so we've got our asymptote. I'm going to put kind of close to the middle-ish there. And then let's get our dots for the tangent curve. Now it is a negative tangent. Usually tangent goes upward like this in this dotted line. And then from the bottom, still going upward. Okay, but ours is reflected. So reflect it to mirror it downward. And then after the asymptote from above going downward. Okay, so there's our reflected tangent curve, and then we can mark our period. So the period is 10 pi. which means this asymptote is at 5 pi. So doing half times 3. Half of 5 pi. Okay, so I'm gonna need a little room here. Those dots are in the way. Half of 5 pi is 5 pi over 2. And then that matches with our -1 on the y-axis. And then if we times 5 pi over 2 by 3, we would get, oops, there, I was thinking 3. 5 times 3 is 15. So we would have 15 pi over 2. Okay, and then let's mark where that hits the curve and go to our y-axis and label 1. And then let's also mark our origin. Okay, so there's everything. Okay, and then now we're going to break it down like we did the last problem where I want to do the phase shift. I want to get all the arithmetic done. So I have 5 important x values. They are 0, 5 pi over 2, 5 pi, 15 pi over 2, and 10 pi. And our phase shift is to subtract 3 pi from all of these. So the phase shift is also the horizontal shift. So I'm minusing 3 pi, 3 pi, 3 pi, there we are. So like before, I'm just setting everything up and then I'm going to proceed with my arithmetic. Notice some of these need a common denominator again. And I'm just gonna get those set up right now in the purple also. And then now let's carry through with the arithmetic. Let's keep it in blue. So -3 pi is the new starting point for the x-coordinate of our tangent curve. Then we've got 5 pi minus 6 pi would be negative, and then pi over 2. 5 pi minus 3 pi is 2 pi. 15 pi minus 6 pi is 9 pi, and then still over 2. 10 pi minus 3 pi, that's sweet, 7 pi. Okay, so these are our new important x coordinates or x values that we will graph soon. But like before, let's also do our vertical shift. So the vertical shift is to go down 2. Usually I just show like, oh, I'm going to subtract 2 from those y coordinates. So I don't really need to make a whole table for that. But I will start my new sketch with those. Okay, so I'm making it bigger, trying to make sure we fit everything. Okay, and then when we do a vertical shift, it might be best to look at the middle, the 0. When that gets shifted down 2, that's going to give us a new axis. So I'm just going to draw a new axis right now. So here's -2. So that was the 0 getting moved down 2. So this is the new x-axis. And then let's get the other two y values. So 1 minus 2 would be -1. And then -1 minus 2 would be -3. Okay, so there's our new axis and then those important y values converted with the vertical shift. Now that we've got the new x-axis ready, we're going to plot all of those x values from the phase shift on this purple line. All right, so let's set it up. Notice the first two are negative. So again, I'm going to try to make it to where it's evenly distributed or evenly distanced apart. So I'm going to say here's -3 pi. And then I'm going to say about here maybe is -pi/2. And then try to keep that equidistance going. I think that looks good. That's where 2 pi is. And then 9 pi over 2. And 7 pi. Okay, so those are all of our new x coordinates or x values. And then now we just want to match what's going on with this. Okay, so I'm going to use a highlighter. So where this highlighted point is from the original curve, it got shifted to be where my new first x value is on the new x-axis. So it should be right there. And let's make a big old bold dot. It should be right there. And then following the non-shifted curve left to right, I do see, oh, my next point was when I went downward, started going downward. Okay, so that's new x value is negative pi over 2, and the y value is negative 3. Okay, so those are kind of close to each other. Careful. Okay, and then my big dot. And then my next important x value is where I have the asymptote. Let me highlight still. So the 5 pi halves got converted. Oh, let me highlight. There it is. To be 2 pi halves. Or not 2 pi halves, just 2 pi. And then we will do our asymptote through there. And then continue onward. Okay, so there's our asymptote. Then still just making the connections between our x values. So 15 pi halves is where we had the point up above, I guess, which would be right here in the highlight. And now I can do my bold. And then my last important point where I did have 10 pi is where it now is back to the new axis. So again, not on the actual x-axis, on our new purple axis. Okay, and then now we just need to connect it and make it look like the shape that we have from the left. Okay, so from this dot, I need to go downward toward the asymptote. I left a gap so I didn't draw over those x and y values. And then I need to pick it up again from a pi and head toward those 2 points. There we go. Okay, so that is our shifted tangent curve. All right, and some of these points are a little messy. Again, it might be better to actually label. So here's negative pi halves and negative 3. This point is negative 3 pi and negative 2. Then we have the asymptote, which we probably should put x equals 2 pi. I'm going to even box that. Our next important point, there it was, 9 pi over 2 and negative 1 is the y-coordinate for that one. And then our last one was 7 pi and negative 2. Okay, so those might make it better to see in case it gets too messy. We could label them instead. Okay, so that's how we can break this one down. Like our other problems, you can double check. All right, so check. Let's get that. Let's check this point, there, that x, that y. And we'll plug it into our function. So I'm doing f of 9 pi over 2 equals negative tangent of, now that x you can write to the side, so it's 1/10 and then 9 pi over 2. And then plus 3 pi over 10 minus 2. Okay, so we need to keep simplifying. All right, let's see how this goes. So I have negative tangent of 9 pi over 20 plus, let's make that a common denominator, 6 pi over 20 minus 2. So sometimes checking gets a little messy. Equals, okay, so this would be negative tangent of 15 pi over 20 and then minus 2. Negative tangent of 3 pi fourths minus 2. Tangent of 3 pi fourths is negative 1. So we have negative 1 minus 2. Well, that's really positive 1 minus 2, which would be negative 1. It matches. Okay, so it looks pretty good. If it didn't match, I would say probably take a break from it and walk away because it's a long problem, and come back fresh without, it might not even be worth trying to find the mistake. One common mistake is the period, accidentally doing 2 pi instead of just pi. Okay, so again, always careful of that. So let me scroll one more time here. The tangent and cotangent always has period pi over b. So whatever b is, pi divided by it. Okay, so that's that though. There's our final graph. If you need one full branch, I mean, we could do that arithmetic and get it like I have in the blue here, but I'm out of space. Okay, so I'm not going to. So if you're curious about that, you can send me an email. I can answer it there. Okay, so other than that, thanks for watching, and I'll see you again next time.